All right, so the first thing that I'm going to do is tell you exactly when you use these formulas, and you guys will have to look back and forth between them, and that's fine. But they're pretty simple to use. Okay, so the first one is P times 1 plus R over N to the NT. That's N and T. Again, not sure why it was rewritten, but you use this for compound interest. Your problem will absolutely say interest compounded, blah, 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 blah. They're ready with me or no? Y'all good? No? Does anybody else not have it? Everybody else got it? Anybody else? Everything else should be the same. Everybody else, okay, y'all got it? All right. Okay, so compound interest, it'll say that we're going to compound our interest either like monthly. They won't say yearly. That's a different formula. You can use this, but it'll be a 1. But the 3 specific ones that they use are monthly. So if I'm compounding monthly, how many times do I do that? 12 times a year. They'll say quarterly. Quarterly is how much? 4 times a year, every 3 months. And then they might say semi-annually. That's twice a year. Did you find it?
Yeah.
Are you sure? Are you positive?
I hope so.
Okay. I'll wait on you.
It was that far back in the time.
Yeah, we're done. This is it. This is our last section, and then we review and test. And then we start with that other packet that I gave you today. Oh, that's what it was. You were looking in today's packet. I mean, Thursday's packet. Is that what you were doing too?
Yeah.
Okay, yeah. So this is the last packet that we just had. Okay. Y'all, it's a Monday. It's okay. Is everybody good? Y'all got that? So the problem will literally say compounded quarterly, compounded semi-annually, compounded monthly. All right. So you'll know exactly when to use the formula. The next one is A equals P times 1 plus or minus R to the T. And this is growth and decay. You've seen this. This is in Math 1. I just know it's in Math 1 because I teach it. Okay. You don't do a whole bunch with it, but you do it. Okay. You use the plus for growth, the minus for decay. The next one, I call it the PERT formula, PE to the RT. This is when the problem says compounded continuously. And then we're actually not going to use the very last one. So this is the last one we're going to talk about. And you have used this. You just don't realize you have. It's P times 1/2 to the R over K. She changed the variables. It should be T over K, but it's all the same. And this is half-life. So just to explain half-life a little bit, I think you've used it before. If you have had chemistry, biology, something like that, earth science, you may have used it. Carbon dating. Have y'all ever heard of carbon dating? That's when you use this. So every isotope has a half-life, which means how long it takes for half of the carbon, or I'm using carbon as the example because carbon dating is what you guys have heard before, for half of the isotope to go away. So your body contains X amount of carbon. When you pass away, those things decay. Obviously, your body decays. And that's how they tell how long you've been dead, is they carbon date you. Okay, so when they find fossils and things like that, they test it and they see how much carbon is left. And when they figure out how much carbon is left, they find out how many years or months or whatever that you've been dead. Okay. So that's exactly what that's about. We are not using this because this is dealing with mortgage and we're not doing it. So then at the bottom, it tells you what all these things stand for. A is your ending amount, P is your initial or your beginning amount, R is your rate, T is your time, N is number of times the principal is compounded, K is your half-life, and then we're not using this one because the very last one, because that deals with that last formula. Okay. So there are your formulas. You can use those all day long. Okay. All right, I'm gonna flip it. All right, $800 is deposited into an account that pays 9% annual interest compounded quarterly. Right there tells you exactly which formula to use. So which formula are we using? The first one, compounded, compound interest. So our formula is A equals P times 1 plus R over N to the NT. A is your ending amount. It's what you want in the end. P is your principal, or what you put down to begin with. R is your rate. N is the number of times that you're compounding it. Again, N is the number of times you're compounding it. And T is how long are you compounding it. Okay. So let's start with what they put in. They deposited 800. That's your P. What is our rate? We need to write our rate as a decimal and not a percent. So our R is 9%, which is 0.09. If we're compounding it quarterly, how many times a year? So that's where that comes from. Again, N is 4. How long are we doing this? 4 years. It says find the balance after 4 years. So that's what you got. Now we literally just put it in your calculator, guys. When you put this in your calculator, I would use the fraction bar. So 800, 1 plus, I do alpha y equals, so it puts that in there and I don't have to worry about it. 0.09 over 4. Close out your parentheses. To the 4 times 4. Literally all in your calculator at one time. Don't try to do some crazy maths. When we hit enter, what do we get? And we're talking about money, right? So let's round like money. 11.42 and 10 cents. That's it. So we're literally just plugging in the formula. Does it get harder? Yes, because if they give you the A and they don't give you something else, you have to solve for that. So that's as hard as it gets. So we plug in, solve for whatever we need to. Look at your next one. You have inherited an emerald ring that had appraised value of $2,400 in 1960. The appraised value of the ring has increased by approximately 6% per year. What is the value in 2011? It has increased. What does that mean? That is growth. Does everybody understand that? So this means growth. So our formula for growth is A equals P times 1 plus R to the T. It's plus because it's growth. If it had depreciated or decreased in value, you would use the minus. P is what you paid in the beginning. How much did they pay in the beginning? $2,400. So this is P. All right, 1 plus, what's your rate?
0.06.
Good. How long are we doing this? How do you figure out how long you're doing it? Right, 1960 to 2011. So what are you doing to those 2 years? Make it easy on yourself. Stop trying to do it in your head because you don't need to, because we're using our calculators. You said subtract them. And that is perfectly fine. You can type it in your calculator just like that. That way you don't have to do the math in your head. I'm okay with that. 2,400 1 plus 0.06 to the 2011 minus 1960. And your calculator will do all the work for you, and you don't have to do it, and it's perfect. What do we get? Round like money? 0.87. That's a comma. I don't care if you don't put commas. That's the first time I've ever done that, and I don't know why I did it. But there you go. Commas or not, it doesn't bother me. So the value of that ring in 2011 will be $46,000, $860. $46,860.87. All right. Everybody good? All right. Check out your next one. Which formula do we use? What does it say? Compounded continuously. So the PERT formula. Remember that we learned that E was just like pi. It's a number that represents, or a letter that represents a specific number. So you're not plugging in for E ever. Okay, so your E should stay in your formula. So $600 is deposited into an account that pays 6.5% interest compounded continuously. What is the balance after 5 years? So what did we put in initially? Remember, we don't do anything with E, it stays there. What's our rate?
6.5%.
Which is?
0.65.
Be careful.
0.06.
0.065. Perfect. And how long are we doing this? 5 years. We put that right into our calculator. 600. Remember, E is either second LN, or the divide key, second divide, whichever one you want to do. 0.65, I'm sorry, 0.065 times 5. What do we get? So after 5 years, it will increase to 830.42. Everybody good? We're not doing the house ones, so number 4 we're marking out. And now this one is going to be a little bit different. How long will it take an investment to triple in an account that pays 8.5% annual interest compounded continuously? So let's start with our formula. Which formula am I using? PERT. It says, how long will it take an investment to triple in an account that pays 8.5% annual interest compounded continuously? So what values do I know?
Rate.
I know the rate. What's the rate?
0.08.
Do I know A or P or T? Well, which one am I looking for? The time. So I have to have something for A and P, right? So what do we know? What do we know? It's going to triple. So the problem is when I look at this, I don't have a value to triple, do I? But what does triple mean? Times 3, right? So if I start with a 1 value, I should end with 3. Let me explain it to you. If I start with 100, I should end with 300. Does everybody understand that? So let me show you something quickly. And don't stress out. You don't have to write this down. I just want to visually show you what I'm talking about. If I started with 100 as my principal, my rate was 0.085. I'm looking for my T. I would finish with 300. That's what we just talked about, right? So how would I even begin to solve this problem? Don't write it down. Just talk to me. How would I begin to solve this problem? We just did logs and exponentials, right? This is where the applications come in. How would I solve this problem with this E? What's the first thing I need to do? Not yet. What do I have to do before I can LN? What? It is an exponential form. No. Why? Yes, remember, we have to, before we can ln or do anything, we got to get that e all completely by itself. So I want to divide by that 100. What happens when I divide by that 100? What is 100 over 100? 1. So that's why we do it, is to get it to be 1, because 1 doesn't matter in a multiplication problem. What is 300 divided by 1? Remember what I just told you. For every 1, when we triple, it's a 3. That's where this is going to come from. So if I see double, what would I do? 2 and 1. If I see quadruple, what do I do? 4 and 1. So I don't have to have a beginning value. I made up a beginning value for you to understand what this problem is going to look like. So anytime I see triple, I'm going to use my A as 3 and my P will become 1. If I see double, it will be 2 and 1. If I see quadruple, it will be 4 and 1. Has everybody got that? So I don't have to have a value. If you want to make values, make them. I made 100 and 300, right? It'll come out to be the same thing. If it feels better to you to make a value, then come up with your own values, okay? So then our rate was 0.085, and we want to know how long. That 1 didn't matter in the scheme of things. So we have 3 equals e to the 0.085 t. You said to get rid of that e, you do what? You already told me. ln both sides. So that's from this week, this past week. ln and e will cancel out. You have ln 3, which we can put in our calculator in just a minute to evaluate, equals 0.085 t. How do I solve for t?
Divide by.
I'm really, really lazy, so I don't evaluate that ln 3 till I'm completely done. Because what's it going to give us? What kind of number? A big nasty decimal, and I don't want to deal with it, okay? So 0.085. So then I literally stick that right in my calculator. ln 3, just make sure you close the parentheses, divided by 0.085. That will give you the most accurate decimal ever. And it gives me what? Time is 12.92. You can put the 4 on there. I don't care. You can put 5, whatever. How long will it take an investment to triple? Compounded continuously, 12.92, or approximately 13 years. That's it. Okay, so there's where your applications of logs come in. We made it a log problem, or we made it a natural log problem with Stacy. All right, look at your next one. Yeah, we're good. For Dave to buy a new car comparably equipped to the one he bought years ago would cost $12,500. Since Dave bought the car, the inflation rate for cars like his has been an average annual rate of 5.1%. If Dave originally paid $8,400 for the car, how long ago did he buy it? What formula am I using? Remember I told you half-life is always like carbon dating. It'll be scientific. So this is not scientific. This is money. What's happening to the car?
It's decay, or it's growth,
It's growth. Why do you know it's growth?
because
The annual rate goes up.
Inflation, right? Inflation means increase. Okay, here's what's happening. Okay, you're a little confused on which one to pick. Remember, if it was compounded, it'll tell you compounded continuously or compounded quarterly. So those two are automatic, you know, because it didn't say compounded. We're taking those off. The other two that you have are either half-life or it's growth and decay. Half-life has to deal with like isotopes, carbon, radium, stuff like that. You'll see in just a minute when we do an example. If you don't have any of that scientific crap in there, chemistry stuff, you know it's got to be growth and decay. All right. So compounded continuously and compounded, what did I say? Compounded continuously and like compounded quarterly. Those will tell you. Half-life is going to be any kind of isotope, any kind of scientific, and then the rest of it's going to be growth or decay. Got it? All right, so this one's going to be growth or decay. We said it's inflation, so it's going to be growth. All right, what do we know?
He paid 8,400 for
What's that?
it.
The P. He paid $8,400, so that's going to be your P. Do we have our rate?
0.051.
0.051. Do we have how long we're doing this?
Yeah, that's good.
That's what I gotta figure out. So I know that that's gonna be my variable. Well, where is my A?
12,500.
Okay, 12,500. Is everybody good? Now it's just solving it. So the problem is I have that power up there that I need to solve for, so I need to get that power down, so we need to think about how we get it down. The first thing you need to do is get it by itself. So how do I get it by itself? What's the first thing I need to do? It's just like the other problem.
Divide by
And divide by 8,400. $12,500 divided by 8,400.
1.5.
And I'm gonna go a little more decimal places just so it's a more accurate answer. So I like to go 4 decimal places. If you go 2 or 3, that's fine. 2 minimum. But when we're dealing with logs and exponentials, I would go 4. Okay. If you get into pre-cal and calc soon, you're gonna go 4. Calculus asks you to go 4. Stats you to go like 2 or 3. Okay. I always try not to round until the very end. All right. So we're definitely gonna go 4. Oh, sorry, y'all. 1.4881. I'm going to go ahead and put these two together. 1 plus 0.05 is 1.051 to the T. How do I get a power down? Nope. I can't. You would take the T root essentially. How do I move it to the front though? You are correct, but how do I move it to the front? I got to have a log, right? You can either log or ln. God, it doesn't matter, okay? Whichever one you feel comfortable with. If you want to stick with ln because it's ln for the e or whatever, you can do that too. They're both the same. I'm going to log both sides or ln both sides. I want to ln because I don't want to deal with log, okay? I'm going to keep it consistent throughout this whole paper, and I'm just going to do ln. So I'm going to ln this side. I'm going to ln this side. You said the power will come to the front, so I get ln 1.4881. I'm going to move the power to the front and get ln 1.051. How do I get this t by itself? It's a normal problem now. How do I get that t by itself? Divide by ln 1.05, 1.051. Put that in your calculator. Make sure you close the parenthesis on the top, ln 1.4881, close your parenthesis over ln 1.051, and you get, anybody?
7.991.
Which is approximately 8 years. And that'll probably be your answers if it's multiple choice, approximately 8 years. All right. How much must you deposit into an account that pays 6.25% interest compounded semi-annually to have a balance of 1,000 after 2 years? So what formula am I using?
Compounding.
P times 1 plus R over N to the NT. If we run out of time, guys, just go back in to the same meeting. I only have about 7 minutes left. All right, what do we start with? Do we have a start price? No. Do we have an end price?
Yes.
What is it? 1,000? It's all right. 1 plus, what was our rate?
0.065.
How many times a year are we doing it? 2, because it's semi-annually. 2 times a year, and for how long are we doing it? 2, right? Don't let this problem fool you. All of this will go in your calculator. It's not like the other one. I don't have E. I don't have that power that I'm trying to get down. It's just a normal decimal. So I'm going to put it in my calculator. Parenthesis 1 plus alpha y equals 0.0625 over 2. Close your parentheses. Whoops. To 2 times 2. You could have put 4 in there and that's fine. And I get 1.03 and I'm going to round it to 10. You can do 09. It's fine. Don't stress out about your rounding. So 1,000 equals P times 1.1310. How do I get P by itself? Divide. So 1,000 divided by 1.1310 gives us 884.17. So that's how much was put into it. All right, when you go to number 8, everybody go to number 7? Number 8 is one that we've pretty much already done. You have to solve, get rid of the E, so you have to LN both sides. But I want to go to number 9. So if you look, it talks about a half-life, right? So this is the one formula we haven't done. So what's your formula that we haven't used yet? A equals P times 1/2 to the T over K. I think she changed the formula. It doesn't matter. It's all the same. All right. It has a half-life of 6 minutes. How much of this isotope is left after 58 minutes if you had 800 grams to start with? So remember, A is what we left or what we want. Okay. P is what we started with. Do we know how much we started with? How much we start with? T is how long are you doing this? 58 minutes. K is the time of your half-life. So how long is the half-life? 6 minutes. That's it. Put it straight into your calculator. 800 parenthesis 1/2, close it to the 58 over 6. And what do we get?
0.9843.
0.9843. So we started with 800 and after 6 minutes, this is a quick one, okay? It took 6 minutes and we're already less than 1 gram of this isotope. Did everybody see that? Carbon takes years and years and years and years and years. So that's why they use carbon. All right, let's look at another one. The half-life of radium-226. This right here is just the name of it. That 226 has absolutely nothing to do with anything, okay? That just tells you what the isotope is, okay? Is 1,200 years. So see, this one takes 1,200 years to split in half. So if you had 1, it would take 1,200 years for you to have half of it left, okay? Suppose we have 52 milligram sample. Find a function that models the mass remaining after T years. How much of the sample will remain after 500 years? After how long? There's a bunch of questions in this. So we're going to start with the first thing. So the first question was how much will remain after 500 years? So we're going to start with that. So A equals P times 1/2 to the T over K. We started with how much? 52 times 1/2. How long are we doing this? 500. And the half-life is 1,200. Stick that straight into your calculator. 52 times 1/2 to the 500 divided by 1,200. And we get
38.9559.
and I'm just going to round it to 0.96. The second one says, after how long will only 18 remain? So how much do we want in the end? 18. We started with 1/2. And then our T is what we don't know. We don't know how long it will take. And our half-life is 1,200. So I'm going to quickly go through this. We need to divide by 52 because I got to get that power down. And you get 0.3462 equals 1/2 to the T over 1,200. How do I get the power to come in front? ln or log both sides, so I do ln of 0.3462. Your power comes to the front, and you'd have ln 1/2. Divide by ln 1/2, then multiply by 1200. So when I divide by ln 1/2, again, it may cut out. You guys can come back in, please. I get 1.5302 equals T over 1200. And then to finish it out, multiply by 1200. And we would get T equals 1836.39. So it would take 1800 years for that much of the sample to remain. Any questions?